Welcome. My name is Jignesh Shah. I manage the engineering and the product teams at RDS, specifically around open source databases, which are Postgres, MySQL, and MariaDB. Today's talk is about Postgres extensions. Quick note of hands of who have used extensions before? None. Well, one. All right, so that's good. At least you're aware. So here's our agenda, right? We'll go through this. We'll start with an introduction. Then we'll talk about how to use them. And I think the real purpose of my talk is how to develop extensions. So if you're on your laptop, you could actually try that out. If you have a Postgres installation, you could actually work with me on that one, right? And then we'll have some food for thought for other advanced topics around extensions. So to begin with, we're talking about Postgres, so just want to give a quick primer of Postgres. Postgres is the world's most advanced open source relational database as they code, and I agree. One of the things that actually attracted me to Postgres in early 2000s was the license. It was very permissive, which means I could do anything I wanted to do with it, right? And that's how I got into Postgres. And initially, I started using it as for doing benchmarks on larger systems, trying to do optimizations. But as I started using it for bare benchmarks, I actually got in love with a lot of the robust features of Postgres. And one thing in particular that always caught my eye was the extensibility of Postgres, and which is exactly what we're going to talk about. What are extensions, right? So Postgres gives you a way to add more features without forking the code, the main code in it. And over the years, it has been able to kind of like allow you to add features that would be more or less consumed as libraries, like how C libraries work. You would be able to kind of load them and execute them. And this, to some degree, spawned up a lot of other developers in writing their own favorite feature, which they could not get in the community. And that led to extensions like pgstat statement, which allows you to do monitoring of the queries that you run and get different statistics about them. PostGIS, which allows you to do spatial databases around it. Postgres FDW, like federated, another Postgres database that would show up. And the one you use, actually, which I find to be quite common with developers, is the UUID, which is to generate the unique identifiers in Postgres, right? I personally think like that is a very popular one. Like I don't know of any startup who is not using that. But one of the other things that I just want to quote is PLV8, because along with UUID, people who use like JavaScript, also who wants to kind of like use the same language as their choice of stored procedures, PLV8 gives you a different language capability in Postgres. And this is all possible due to extensions. So how do you use extensions, right? When you go to any Postgres installation, you are able to do like a select star from PG available extensions that gives you the extensions that are pre-packaged for you on that setup. So if you use like a cloud provider for your managed database instance, this command would still work, and it would show you all the available extensions that are preloaded on that one. The way extensions work, as I mentioned, is it's a set of files and libraries, which means it is loaded at the time of as files directly on your setup along with your binaries. And whatever those binaries are, they would be visible through this command. So it actually goes through a call into the file system, lists out all the functions available, and shows them back. So this is the best way. There is an alternate version of that, which is the PG available extension versions. So if you have multiple versions of the same extension, you can see multiple lines for each one of them. The most popular one, like by default, people would look at the available extensions to find what's the latest version or the default version. available on that system. So once you've selected your extension, the way you would use that is as simple as doing a pg create extension pg start statements, right? That's how you first initialize an extension. Mind you, an extension can be a little bit global depending on how you use it, but like from a Postgres point of view, it's always applied at the database level. So when you create an extension, it actually creates an extension for that specific database that you're connected to. If you have multiple databases and you go to a different database and list out the installed extension, it may not show you unless you've created it up there. But many extensions like pgstart statement, once installed, works globally because the way they work out there is basically they are loadable modules, and we'll talk more about that as we go on. So once you have created an extension, you can now use those functionality provided by that. Like in case of like pgstart statement, it gives you a new view of pgstart statements that you can run queries against. Question?
So the 4 lines that you fetched in the previous slide, those are extensions that are not created yet, but they're available. They're kind of baked into Postgres.
Yeah. So like typically what would happen is like these are the ones available for you to create. So think of it like the administrator has given you permissions that these are already available and you can actually create that. So there is a PG select star from PG extensions, which would show you the ones that are created for your specific database, right?
And you can only create one.
You could actually create as many as you want.
No, I mean the PG stat statement that extension you can only create one.
Yes, on that particular database you can only create one, right? So,
Is
yeah.
there any example you create multiple instances for the same extension?
In this particular case, like most of the way the framework works right now, you can only create one of a specific version, and then you can do an alter, and we'll talk more about that as we kind of get along, right? So once you have created, like, you created, you used it, and now if you do like a select star from PG extension, you see that available. I actually particularly added PL/PGSQL because that's actually one of the default extension that has been enabled for, I think it's like 9.1 days. So that it used to be like previously, if you want to use the PL/PGSQL language in your stored procedure function, you had to first create it as an extension. Now it's a default extension that's pre-created for you always on new database create. You do not need to restart. Yeah. Okay, so let's talk about like, how do you actually manage Postgres extensions, right? Once you have installed it, and then say, for example, you have a new version available, which maybe somebody installed it on your setup already, which means now you are able to upgrade it. So the way you would upgrade that is you would use like the alter extension name update. Remember, upgrade out here is update. It's one of those things that you will keep forgetting, like, is it upgrade or update? One of the interesting things to know is you can actually update to a specific version if you want, and the way you do that is you say update to a version. If you do not use a version, it will update to what is the default version on that setup now. The default version can change over life of an instance, which means like you could actually start with something that's the default, and then you install more versions later on, and the default could change, right? So anytime you run an extension version name update, it may actually take the default at that point of time and upgrade to that version.
What decides what the default is, I guess?
What?
Because if you have multiple versions of one extension installed.
Yeah, so I'll talk more about that as we go on, like how do you figure out like what's the default, and we'll talk about that, right? To remove an extension, you can always do like a drop extension name. Sometimes extensions have a dependency on other extensions, so you could actually drop all of them together using the cascade function. Similarly, when you're creating an extension, you could actually have dependencies to create extensions before that extension. So the cascade is also available on create extension. So if you have, like, for example, PostgreSQL, which depends on, like, say, Tiger decoder or something, you could just create that extension with cascade, and it would create all the extensions needed for that one to be created.
So when you show the
it would show that in the PG star, select star from PG extensions, all the dependencies. Yeah. Okay. All right. So what we did talk about was like, we already talked about this, like, but one of the things to kind of like be aware of, all these are shipped as C libraries, which means like most of the time they would be loaded on demand. So whenever you use an extension function, it knows like, oh, this is coming from this particular module, and it would load that on demand. Now, there may be cases that you want them upfront, right? So in that case, like you may actually have to like preload them, and we'll talk more about that later on. So the way you would do that is like, even if you want to do it on demand, there is a load function available. And the reason the load function is available is like, not all things that you develop may be deployed as an extension. Some of them could be just loadable modules. So that's kind of like one of those unique things about extensions. We always think extension as create extensions, but then there are some extensions which are just loadable modules. And the way you would use them is just say load module and start using the function.
So this is specifically just modules can only just expose new functions rather than
Yes.
loading the queries.
Yeah.
Okay.
So for example, like auto-explain is a loadable module, right? Like there's no separate extension. And by loading it out there, as soon as you load it, it creates a function which says anytime you have a query that is running longer than a certain duration, it would automatically throw the auto-explain plan, explain plan in the logs. So that's an example of loadable modules, which is like you don't really need to create one. You just have to load and make it available. And if it's enabled, it would automatically execute those functions.
Do you know why the UUID generation isn't implemented as a module?
So everything is a module, and the end result is like, do you have to create an extension or just load it? So UUID in particular is actually an extension. So you'll have to do a create extension UUID, OSP. It's actually very specific, OSSP-UUID. And then once you have that, then you have the function available.
The question is, as a writer, how do I decide to write a module or extension?
Right, so we'll talk more about that in the development phase. So that will be something that we could talk about, right? So moving on, right? There is another type of modules that is available which are very specific to decoder logic, and those are called as plugins in the documentation. And the way to look at that is like, hey, for example, if you're using logical replication to go from one database to another, and you want to use like a specific plugin, you could actually use that during when you use the pgreceive vault command. Like some of the examples of that is like the test decoder, decoder raw, and vault to JSON, where vault to JSON basically says anything that I'm streaming change tracking from this database will be dumped into into a JSON format that can be consumed by something like Kafka and other things that you can push to other deployments. So that gives you like the whole power of the extensions framework in Postgres with different ways of using that.
Is that going to be unnecessary with the full wall JSON format that's in Postgres 15?
So that may be, so that is one, those formats would be going directly into the log files. These are actually tracking the WAL files to a different system for replicating changes through WAL.
Okay.
Yeah. How does all of this relate to AWS? Because on AWS, we do provide those extensions. So if you deploy a managed Postgres service on AWS, you do get 85 plus extensions out of the box. Like some of the new ones that we have recently added are MySQL FTW, TDS FTW for SQL Server and site-based database, Oracle FTW. So at this point of time, we have like, you can essentially map all relational databases from Postgres and do it like as a federated story. And apart from that, we also have integration into AWS Lambda functions and other things that you can just call directly from the Postgres server and execute that as an extension.
As a function in your queries?
As a function in your queries. So you could do like a select AWS Lambda, I don't remember the exact function format, but you basically say like what's the Lambda function call with the input and output, and you get the result in a function return value that you can then process.
And how is that encoded? Like is that Lambda or like it's just a JSON?
It's a JSON that you get better by. Yeah. So now comes to the meat of our talk, which is like, how do you write your own extensions, which is kind of like an interesting topic. I got interested just to kind of learn about how the setup works. And the way to think about it is everything is done through a framework. And the framework at bare minimum requires a control file to kind of explain what the extension is about, and a script file, which is a set of SQL lines to describe what you are delivering as part of that extension, right? So at minimum, there are 2 files required. Typically, like you would see 3 sets, like 2 files for like the describing of the control and the SQL files to initialize it, and the loadable modules, which will contain all the functions. So the first thing I want to talk about, like, if you have to develop like a pure SQL only extension with no C files and other things, you could actually do that in the current extension framework. The way you would do that is you would just create 2 files, which is demo-09.sql with like a function describing what you're doing, and a demo.control, which explains what the extension is all about. So in this particular case, the demo.control basically says it's a comment, a default version. This is where it pops up, like what's the default version on your setup. Relocatable. This is like the C relocatable functions, whether you're using it to kind of, when you compile it. And then if you have a dependency on other extensions, you could actually have a comma-separated list with requires, and a directory of where this particular extension is available to kind of load up there. And so in this particular example that I'm showing out here, all you're doing is like you're just creating like a select demo version, which is equivalent to select version call. So you have defined a new demo version function, and it returns 0.9, right? That's your function call. And then you create these 2 files. All you have to do is copy them to Postgres/share/extension, and now you have this new extension available in your PG available extensions. So as soon as you have copied it, you have to do maybe a session restart sometimes, just your session, and you would be able to do like a create extension demo. Most of the time, the session restarts are only required like if you have changed those library version and one is already loaded. But if it's a brand new one, it would just work in that same session also.
So those 2 files would go in a subdirectory of
Yeah,
that?
the specific directory is the share extension. You would just copy it in that directory.
Just those 2 files, right?
Yes.
And then can you specify versions of your dependent, like allowable version ranges for your dependencies?
The PG stat statement allows you to, the require field allows you to specify the dependencies, but I don't remember if it allows you it used to be a case like we could do a dash version, but I'm not sure exactly on that. But right now it is like, what are the dependent extensions that needs to be pre-created on it?
In RDS, customer cannot expose it.
Yes, yeah. So in this particular case, this is provided you have access to the file system. In a managed database offering, the provider does all the security work for you and then provides those extensions to you, right? Now, if you have to use like a C function, right? Like what we talked about was a SQL function. If you want to go quickly for the next one with the C function, it's kind of like similar, except now you say like, I have a module path name, and that refers to a C function file, which would be saying like, that would be the implementation of my function rather than the SQL function. Why do people use C? Because it's faster than even the SQL. Like SQL still needs to be interpreted to be executed. The C runs at the native level. So, minor differences, there is a module path name that gives you like where to find that library to load and execute that. Same concept. I'm now changing the default version to 1.0 instead of 0.9, something that I've highlighted. And, C file is actually, Postgres has a very great way of like writing simple C files, there are two main macros that you need to remember. One is the PG module magic. It sets up all this magic required for the extension, so you don't have to worry and learn the details of the Postgres internals. And all the functions that would be reflected back or exported back to the main call would be through the PG function info v1. So that helps you as like a stub to kind of like define which functions would be exported and visible in your main program. And after that, I just write like a datum demo function call. Everything that you return is a datum in Postgres as when you talk about extensions. And then in this particular case, all I'm saying is like, hey, now I'm returning the text from C string to text, which is like the data type conversion from C to Postgres. And that's my version string, which is demo extension 1.
If your extension library has dependency on other libraries,
You would add that in the control file, and you would actually load that.
you have to.
Yeah.
The second thing is, it seems like you can write an extension using C++. And
Yeah.
play around with a C++.
Correct. So I'm going to talk about that a little bit later. I'm actually running out of time. I have like 20 minutes, so I'm going to speed up a little bit. So the make files that you could actually get is standard. Like there is a standard stuff for all make files provided by Postgres. So the ones I've highlighted is you can take the standard from one of the existing extension and just change these values for specific for your extension. To be honest, if you kind of like look at the details, all it has is like what's your C module, what's your version number that I need to kind of make sure I'm aware about, and every extension is expected to have a .control file, so it knows like what are the standard things it needs to look into kind of loading the module. So whatever you were doing manual copy before, now you can do it with this make file, and you would just make an extension with make use pgaccess equals 1, so it knows all the Postgres variable, compiles the C code, copies it to that specific directory that I mentioned earlier, and now you would actually see that library available in your Postgres installation. And now if you drop the earlier 0.9 extension and reloaded it, because now it has a new default version that I just pushed, which is 1.0, it will now load 1.0 when you create an extension and you see the demo extension 1, right? Now we'll talk about, like what I talked about was replacing an extension, so let's talk about like if you want to do an extension upgrade, how would you actually do that in your code? Similar things. Now the way I'm actually saying is like, the best way to do an extension upgrade is keep your old version for backward compatibility and define a new version. So in this particular case, what I did was like I created a new demo 1.1 function call, defined it with my changes. The only change I have is like, hey, this is now extension 1.1. Same thing, everything else remains the same. I still have the old function, which is my backward compatible. Compile it, and now I change the make file to say it will now have demo 1.1 also, and one of the things I include is like, what is my upgrade path from 1.0 to 1.1? And the way you would provide that is like there is a standard naming format for all upgrade paths, which is extension -- from version -- to version .sql. That's the expectation. So in this particular case, I created this new upgrade path, which says it replaces the function which was calling demo earlier. Now it will call demo 1.1. Everything else remains the same. In this particular, like when you execute this function, now when I look at the function, assuming that I already had executed my previous one, which was running on 1.0, if I now do an alter extension demo update to 1.1, it would create this, create and replace that upgrade path, and then create this extension. So now when you execute that same function, you get 1.1. Right? Now, if you do the select star from PG extensions, you will see that it has actually upgraded from 1.0 originally to 1.1. So that's what the top line and the bottom line shows. It basically shows that the part that you have created, the ext version has changed from 1.0 to 1.1, right? Going forward, like this brings up a question. How do I know how many upgrade paths are there, right? And so there is a specific command available for you to list that out. Now, so PG extension upgrade path, specific file name, it traverses through all your upgrade files available out there and gives you the path. Now, one of the interesting thing to know about extension is this framework is simple. It basically assumes everything is an upgrade. So technically, you could actually have a 1.1-0.9, which in your world would be a downgrade, and it would still show up as an upgrade. So the system is not designed to be smart enough to kind of like prevent you from doing anything. Anything that has an upgrade path would be available for you to run that. So, and you would see gaps also, right? Like, so if an upgrade path is not available, it will show up as gaps. And there are some reasons, like in some cases, like you don't, you may not be able to safely upgrade them. The only way at that point of time would be to drop the extension and recreate it. And in those cases, you won't have an upgrade path available. Right, so that kind of gives you like how do you see in a given system what are the upgrade paths available for an extension and use that to upgrade. Now we go a step closer. Now you have gone deeper, you have figured out how to upgrade extensions. Now you want to define like your own custom GUC values. What are GUC? These are the Grand Unified Configuration, a long tongue twister name. But essentially what it is, a server config. You can change that in PostgreSQL.conf, restart it, and those values will now be available into your extensions, visible for you to kind of make system-wide changes as the user can indicate their changes. Same thing, right? If everything remains the same, you just add a couple of more include files, the guc.h basically, and now you could define your own custom configuration parameter for your extension that you can get from the user to set up. So in this particular case, I'm showing a simple parameter value which says my values are 0, minimum, the integer max, it basically says my upper side is like the max of the integer, and it's user set because you could actually have parameters which are only user visible. You could have user set, and you can have super user set. So most of them would be set at the runtime, which means they are super user. And those things, right? Like, so the standard parameter, you could actually get more details from the Postgres community documentation, but this is an example of like how you can use like parameters in your own extension. Same thing, compile, ship it back up. Now here's the thing to remember. What I said is most of the values in Postgres are dynamically loaded. So when you're using something like server configs, one change that you need to do is get them to be preloaded on every startup of every session. So the parameter that you would change is in your server config, the GUC parameter shared preload library, you would now add your library that you would always preload on any session connect so that that parameter is available. So that's the difference. Like if you use any of the GUC parameter or certain things in extensions, you need to make it as a preload library. Preload library, essentially, if you change something, restart it, and then you could just restart your session, and then the new library would be available for you. So in this particular case, it shows like if I use the show demo.param1, it shows like the value has been set to 0 because that's what I set as the default value of the code. If this function returns an error, then the parameter was not found or your library was not found, so it's not available on the system. Correct? Going a step further, like how can you do more function calls from within your extension? And this is where Postgres has thought through it, like how you would have your own client libraries to run your own SQL functions. Your extension has a similar mechanism using what is known as the server programming interface. It basically provides you with a set of standard commands which would allow you to run, connect, execute queries, go through the various functions, and even kind of like collapse them into like transactions. Like you could say, start transaction, run bunch of queries, commit or roll back depending on the output. So just to kind of show you an example, in this particular case, everything is building up on prior code, so I'm adding it on a step-by-step basis. So now I'm actually creating a new version out here, which is demo 13, right? all it's is going to do is it's going to run its own internal command and get some execution and do a processing of that as my result back. So in this particular case, you would see I do set up a SQL query, which is, for simplicity case, I'm saying I'm running the select version on my standard database. The way I would execute that query is I would initialize my return value, connect the database as is. SPI Connect, the way it works, it uses your existing credentials and does the next query. So there is no other magic you have to worry about doing authentication, re-authentication, and other things. You're basically saying whatever user that has come in is executing it, it's being executing as the same query back. Once you get the return, once you execute that query using SPI execute, you now actually have a post-processing that you can say SPI processed. It kind of gets everything into your value that you can then go and traverse through for your result values. So in this particular case, what I'm doing is I'm setting up another buffer, taking the output, adding my demo string SPI 1.3, and concatenating it with the return value of version function call. It's a simple join that I'm trying to do, right? And if this works, the expectation is you get demo extension SPI 1.3 concatenated with select version from your existing setup, right? Same thing, go back, make, compile, make install, and if you then recreate that extension that we just did, this time when you do a demo version, you'll see, like, along with the demo extension version that I got, it also gives me the select version output of that particular database. So in this particular case, I was running it on my Mac laptop, and so it's showing me the version output from the Mac laptop. So based on what we have seen are like the ways you can actually grow from a simple few lines of extension code and grow into like a detailed way to kind of like implement your own feature in Postgres. So I'll take a pause out here. Then I want to talk about a few more things. There are a couple of things, right? So I'll cover that in the language section. So the next one that I want to talk about is demo FTW. Till this point of time, we have talked about basic extensions, but Postgres gives you a way to do more than like simple functions, right? There is a framework to do foreign data wrappers. Foreign data wrappers essentially allows you to talk to other databases, get the data from that other sources, join them with the existing databases, and return the query. And Postgres now gives you a way to kind of like define your own foreign data wrappers. Again, so everything remains the same. There is a standard format, so if you look up on the foreign data wrapper, there are three main functions that you need to define, which is the FTW handler, FTW validator, and demo FTW. Like, you know, you define this and you have your own foreign data wrapper extension available. Of course, these are not the only things. There are a set of another 12 functions that you need to kind of define to kind of get like the full feature of an FTW. With this, you could define your own system, need not be a transactional system on the other side. It can be any system where you, if you have the definition of there, you can essentially create your own foreign data wrapper. So this one is a powerful feature. I think using this, you essentially see in the whole, you know, larger community work, foreign data wrappers to multiple databases. You see like things like S3. You see things like ZomboDB, which kind of connects you to like Elastic Cache. The possibilities are endless. The next one is like you could actually use that to define your own language. So one of the things I talked about like was a default language is always pre-created for you, which is PostgreSQL, the Postgres SQL language, right? Essentially, you could use a similar concept to write your own language. And in this particular case, I'm kind of like showing you the stub of what you would look, what a demo language would look like in that create statement that I showed you. So essentially, you would need like 4 specific create functions, which defines your call handler, inline handler, validator, and now basically using these 3 things, you can define your own language in Postgres. This is pretty powerful. Like you could actually use that to connect it to compile C through this way. There are at least like multiple languages like PL Python, PL Java, PL V8 also uses a similar concept behind the scene, where essentially what happens is like you're saying like any new language that you define has a validator to kind of validate is this language correct or not. Once once you say that's correct, it's added to the system as a valid function. So every time you execute the function, if you execute it as a stored function, then it calls the demo and call handler and executes it. So it's just giving you a stub. You define your functions. It passes the language or the syntax that you have to that function calls. It passes it, determines what should be the result value, and returns back.
So your language is interpreter. It's not compiled.
So
this cannot be compiled.
So it can technically be compiled. So like the way you would do that is you could define your own way on where you want to compile it.
I can take Java and do this.
Sorry?
I can do, for example, take a Java.
So PL Java is a language that's supported using the same functionality. So the way it happens is you could actually do a couple of ways. You could do that in the validator to make it a valid one. And whenever you do a call handler, it takes that valid code, compiles it, executes it, and returns back. And there are ways to kind of like do a precursor.
We're running this only in like Postgres processor, which doesn't have a Java runtime.
So there is a libjvm that is available in the Java runtime that it uses to kind of do that. I don't have the exact data, but like it essentially works on the same work, right? Like you have a dependent library that's available for you to execute that. The call handler takes it, executes it in that environment, gets the return value, and processes it. This is just like a tunneling one into that library. So you need like a way of handling that in a library. So in Java, it's a libjvm. I think there is a similar library for Python that it uses as a way. People have used it to create like multiple different languages. There is PLR and so many other ones. So all of them uses this same standard procedural language framework definition that is provided as part of the extension framework.
That language runtime into the Postgres.
Yes, yeah, right. So all this point of time we have talked about like how you can slowly do that. And there are a few more hooks that are available that I'm not going into detail today. One of them is specifically shared memory hooks. So essentially, if you want to do like your own counters and things that you want to maintain in runtime, there is a way to do that for extensions. It's a detailed topic by itself, so I'm not covering up there. The second one that I'm not covering is the PostgreSQL hooks. Hooks allow you to change the behavior of existing Postgres. So they are dangerous as well as opens up new avenue to kind of do it in a completely different way than existing behavior. So there is a way you could actually modify an existing behavior in Postgres with the hooks that are available in Postgres. The Postgres hooks needs to be predefined, and then you override that existing hook implementation and execute it in a different way. So so an extension can change behavior of an existing function is what you can get with this. And then there are ways you could actually use this extensions along with trigger data. So like anytime you change data, you're triggering, you execute triggers. So those triggers can be used by extensions to do different things. So these are like some of the advanced things that you could do. Once you have understood all of these concepts, you're ready to go and write any extension you want in Postgres, and you don't essentially have to do any forking of the core Postgres at all.
What are some of the things you can hook into?
At this point of time, there are ways to hook into query plans, optimizers. I think there are a couple of places on optimizers. The most common ones that I've seen are, boy, I had a list of that. Jonathan.
Check password.
Check password is a common one. So you could essentially say, like, before you kind of change the password, like if you want to do your own implementation of validations, you could do that, and so on. So this allows you to kind of allow you to kind of expand way beyond just adding function. Hooks allow you to change existing functions.
The documentation on these public books.
Everything is public. Everything I've talked about is on the public documentation. Yes. Well, so
But it's not in the official Postgres documentation. There's like a GitHub repo where someone took it on themselves.
Yeah.
to document.
So for the hook specific ones, you may actually also have to read the code. Hooks are a little bit special. The reason I say it's also like dangerous, like if you don't know what you're doing with it, you could corrupt your data, right? So that's why those things are not.
But it should still be public, document.
It is still in the public, but I think the documentation is getting better and better. But I think some of the early hooks are only for developers, internal developers, to kind of understand and make sure that it's safe. Some of this thing is evolving. With each version, it makes it easier and easier for new developers to change things. So like even the number of hooks keeps on increasing, release over release, and so on. So with that, to my summary slide, extensions can help extend core Postgres functions without forking the core Postgres, which means you can still do more things than you intend to do without modifying the existing core. They're easy to develop, easy to use, and this is how, I think the growth and popularity of Postgres is happening because of extensions. With that, thank you very much for your show, for showing up out here. I have 3 minutes for answering any questions. All right. Thank you.